implementing data types. This nugget is all about data types. We'll go through the many data types we have to work with here in SQL Server, and also how to create our own custom data types. So we're going to kick things off here with just a quick overview to talk about the categories of data types, what kind of objects we can apply data types to, and then I've got a nice chart that lists all the data types, their ranges, and we'll go over them all just so we can get a refresher here on all the different data types in SQL Server 2012. Then we will talk about some things to think about when it comes to data types. We'll go over converting. Conversion's a big deal when you're working with data, whether it's coming into SQL Server, going out of SQL Server, or using it internally for comparisons and calculations. Converting data types is something that we just need to know how to work with. Whether it's casting, converting, or parsing, we'll cover it all. We'll also talk about GUIDs, globally unique identifiers, talk about performance implications, when we should use them, when we shouldn't use them, where we should use them, how we should use them, all that good stuff. We'll talk about sparse columns, nulls, and then we'll also get some guidelines for using the appropriate data type. We always want to use the right data type for the job, and we'll talk about why when we get there. Then we'll get into the virtual Nugget Lab. We'll have a couple of demos here. We'll start with just a general demo, really going over conversions and using cast, convert, and parse, and try parse, try cast, try convert, and also sparse columns. We'll talk about sparse columns and column sets, a couple of things that are really good to know when it comes to storing data. Then at the end here, we'll take a CLR demo. We'll create our own CLR data type. I've got one created it in C#. We'll briefly go over what that looks like, and then we'll see how to register that in SQL Server, make and use our own data type. I'll also talk about how to use data type aliases, which is using and creating your own data types based on existing built-in data types. Let's get to it. So for our data types overview here, this is just a quick refresher on all things data types. So what is a data type? If we had to define it, we would say it determines the kind, size, and range of data that can be stored in an object. The kind of objects we're talking about here, columns obviously for tables, those are going to be the big ones. Anytime we create a variable, we need to assign it a data type. Expressions and also parameters. Those are going to be the big four objects that are going to hold data, so we need to specify the kind of data that they will contain. Three categories of data types. Built-in. These are the ones we're all used to. Everything you see over here is a built-in data type. We also have user-defined alias data types. And these are the ones that I was talking about a minute ago where we can create our own data types based on these existing built-in data types. And then user-defined CLR data types, common language runtime, the data types that we can build using the .NET framework. So you can break out your favorite programming language, C#, Visual Basic, whatever it is, build an assembly, and then we can register that assembly inside of SQL Server, create a type based on the type inside of those assemblies, and then we can start using them in SQL Server. Let's go over some of the built-in data types. So on the numeric front, we have exact and approximate. And really what this boils down to is exact numeric is going to cover the needs of 99% of the applications out there, especially in the business world. The only reason you should ever use approximate numeric value is if you're dealing with numbers so big that precision just doesn't matter. And that's really just going to boil down to the scientific community for the most part. Let's go over some of the exact numeric data types here. Bit, obviously true, false, on, off. We've got a nice range of integer data types to store small ranges of numbers all the way up to ridiculously large ranges of numbers. Small money and money you're generally going to want to stay away from for storing currency values because they're not ANSI compliant. They're SQL Server, Transact SQL specific. And besides, decimal is kind of a nice one-size-fits-all data type for storing things like currency and anything that requires decimal places. Numeric and decimal, you have precision and scale. Precision is the total number of digits. Scale is the number of digits to the right of the decimal place. So those are all your numeric data types. On the character data type front, we have both Unicode and non-Unicode data types. Anything with an N in front of it is Unicode. And Unicode is just really a worldwide character encoding standard that is going to simplify software localization because you're going to support foreign languages. Some foreign languages are wide, meaning they need more space to store their characters. So Unicode characters, Unicode data types take up twice the storage, but again, you get multilingual support. Non-Unicode means you're going to store it in like English per se, and it's not going to take up as much, but again, you're not going to have that multilingual support. So be careful when you define your characters. Make sure that if you're using non-Unicode strings, that you don't plan on supporting multiple languages. Now, as far as the data types themselves, we have char, varchar, and then we have the Unicode versions of each of those, nchar and nvarchar. We also have text and ntext, but you can see they're highlighted in red. Anything highlighted in red here is deprecated because we have other ways of using them, and that is with the max property when we define our length. Now, the difference between char and varchar here, char just simply means that it's always going to allocate that amount of space. So if you create a variable, say, that's of type char with a length of 10, and you put 3 or 10 characters in there, it's always going to take up 10 characters. If we were to take the same scenario, only with a varying character column, then it would only take up 2 when you put 2 in it, it would take up 10 when you put 10 in it. So the idea here is use char when you have a consistent length of data going into a field. And I can think of like codes, product codes, or states. State abbreviations are a good one, char2, right? Perfect for that kind of thing. And then varying character for everything else, anything that has varying data within it. Binary strings we're going to use for things like images, documents, audio, video, that kind of stuff. And again, image deprecated because we can use max here on var binary. But binary and var binary work the same way as char and varchar. Oh, and one more thing here. This is a good exam tip. Anybody know what LOB stands for? It stands for large objects or large object data, and that's what text, ntext, and image were originally designed to store. Well, now we use the max length property on our existing data types to store our large object data. Moving on to our other data types, these are all special purpose data types, starting with unique identifier, one of the more popular ones here. This is a globally unique identifier, the key word there being globally, meaning it's unique across processes, machines, and space and time for that matter. And the idea here is that if you have multiple applications or you're integrating with external applications, this is the way to go because it's easy for applications to generate these IDs on their end. They don't need to go to the database to get the next auto number, which may be impossible in the external application scenario. Row version is taking over for timestamp, and it's not, as the name implies, an actual date and time, but it's an internal counter. So anytime an insert or update statement hits a row, SQL Server will internally increment that counter. It's a pretty good data type to use for ETL or data warehousing scenarios where you need to know when a row has changed. XML, as the name implies, is how we can store XML data in our tables. We can do both typed and untyped, schema or schemaless. SQL variant is how we can mix and match many of the built-in data types in a single column. Hierarchy ID is how we can create a tree, but we're not actually storing a tree in this data type, but rather storing pointers to where the data is within our table so we can represent a tree. Cursor is a data type that we can use in variables and output parameters and stored procedures that contain a reference to a cursor. Table also used for variables and parameters, so we can pass tables around. Sysname is going to be good for those administrative scripts where you're referencing object names, SQL Server object names. And it's basically the same thing as doing an nvarchar, but it's a little safer and it provides a level of self-documentation. So that's definitely going to be the recommended way to go when you're referencing SQL Server object names. On the date and time front, we've got a lot of them. We've got one for storing date, one for storing time, one for storing a small version of date, standard date time 2, which gives us a larger range from the beginning of time to the end of time as we know it, and then date time offset, which also adds the time zone to it. We have a couple of spatial data types here. Geography is going to be good for plotting out those GPS latitude and longitude, so what we call round Earth data. And then geometry is good for planar, flat Earth data. So there's a quick look at all the built-in data types. They're going to cover most of our needs for SQL Server data storage. If they don't, if we need to refine any of them, we can use alias data types, or if we need to create our own custom data types, then we can fire up .NET and create our own CLR data type. Let's move on and look at some data type considerations, things to think about when you're storing data either temporarily or permanently. One of the most common things you'll be doing as a database developer when writing code, whether you're writing simple queries or whether you're writing a big honkin' stored procedure, is converting. And that's just the process of moving data from one type to another. Often when you're bringing data in, pushing data out, or combining or comparing data, you may need to convert it. Conversions may happen automatically, what we call implicit conversion, or we may need to do it by hand, writing code specifically to do it, and that is known as explicit conversion. And explicit in the world of programming is always better than implicit because it makes code more readable. And we've got many ways in T-SQL here to help us out with explicit conversions. Cast is the ANSI SQL way of doing it. Just simply cast an object to a data type. Convert does the same thing cast does, but it's not ANSI SQL compliant. It also has a third parameter on it that allows us to style and format our data. I'll show you that when we get into the virtual Nugget Lab. And then parse is new here in SQL Server 2012. That does the same thing as cast and convert, but we can also optionally tie a culture to it. So we'll look at all three of those here in the virtual Nugget Lab. There's also try versions of each. So cast underscore try, convert underscore try, parse underscore try. And the difference there is that rather than return an error when the conversion fails, it will return a null value. So it's a great way to test out our conversions. Let's move over here to GUIDs. So GUID, again, globally unique identifier. It's a way that we can guarantee uniqueness across space and time. But one of the downsides to it is it's huge. It's one of the biggest data types. So you want to avoid indexes as much as possible. And some people get in trouble here because when you use the designer to create a table and you say add a primary key, GUIDs are fine for primary keys, but the big thing there is when you add a primary key, a clustered index also automatically gets added on it. So separating those out, use them as primary keys fine, but do not use them as clustered indexes. Integers are great, probably the best choice for clustered indexes. On the null front, you should always try to specify the nullability property whenever you're defining the columns in your tables. If you stick with the SQL Server default, everything will be null, and that could lead to some data integrity issues. But null means unknown or missing, which basically means it's not zero or an empty string, and you cannot do null comparisons. Null equals null? Nope. And that is the ANSI null default. There is a property called ANSI underscore null that you can set so you can control this comparisons, but just be careful with that switch. Sparse columns are actually really cool. So a sparse column is it's a regular column in SQL Server with the isSparse property on, which tells SQL Server to optimize that column for null storage. And the really neat thing about sparse column is something known as column sets. So let's say that we have a table that contains a bunch of special purpose columns that has features in an application that are rarely used. Maybe like address 3 and address 4, maybe description 2, notes 2. Those columns that are just rarely entered. So the idea with a column set is that SQL Server will actually take all those sparse columns and give us a computed XML column that is updatable. And the nice thing, this actually makes it really easy and gives a performance boost to the application because now it can just work with the column set rather than each sparse column individually. And we'll get an example of that in the virtual Nugget Lab. Let's move on to some data type guidelines. And the big one here is always use the right data type for the job. This has a lot more implications than you think. The big ones are going to be efficiency and performance because the query optimizer is going to come up with a plan depending on what data types you use. So if you're using a big int when you could be using an int, then you could be slowing down your query. And another good reason here is that data types, since they describe the type of data going into the objects, provide a level of self-documentation for ourselves and anyone else using our database. Some other tips right from Microsoft is avoid using any deprecated data types. If there's any chance you're going to be working with non-English data, use Unicode data types, and then always try to use sysname data types in your administrative scripts rather than nvarchars. All right, let's head into the virtual Nugget Lab and work with data types. We'll start with conversions. We'll go from there and work with sparse columns, and then I'll show you how to make alias data types and even a CLR data type. And we're in. So I've pre-launched SQL Server Management Studio. We have a new project inside of our solution, 06.datatypes. And we're going to start here with some data type usage. So I've just got some very simple ways to use cast, convert, and parse. I'll give you just a really simple bare bones example, and then I'll give you a real good example, and then I'll show you a little bit more about this new parse function. So let's switch databases here to Nugget Demo DB. And the first one here, I'm just writing just a little query to go against the course table that's going to grab title, completion date, and then use cast against our completion date to cast it to an nvarchar with a length of 30. We'll see what that does. And again, cast is the ANSI SQL standard. Then we'll use convert to do the same thing, but we're going to use the format of 110, which will give us a specific date style. And remember, convert is the T-SQL specific way of doing conversions. And then I'll show you how we can use parse, which again works the same, but we can also apply to it a culture. In this case, we'll use the ENUS code. All right, so let's highlight all of this, hit execute, and we can see here, title here's the completion date as it sits within the database, and then here's what it looks like when we cast it. So you can see when we cast it, it's going to give us the text representation here. Converting it, same thing, but again, we're applying a style. In this case, it's month, month, day, day, year, 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 year. And then parse, you can see we're just parsing it using ENUS, and this is what it looks like here, year, month, day. How about a real example here? Let's say, for instance, that in our Nugget Demo DB database, we have this Learner Nugget info table, which contains a progress field, which tells us where in a specific video that user left off. So the next time they come back, we can start from that point on. But let's say that we wanted to take all of their viewings across all the videos that they've watched in the CBT Nuggets library and get a total time watched broken out by learner. Well, in order to do that, we're going to need to take the seconds, convert it to a data object that we can use then the convert function on with the style parameter to get something that's in the format of this. So we can get the friendly version of hours, minutes, and seconds. Well, the 108 flag here allows us to do that with the convert function. So the first thing we're going to do is just take those seconds, add them up by using a group by on the learner ID, sum up all their progress, and then we'll get a data object that we can then use with convert. Then we're going to convert that to a char 8 along with the 108 switch, which will give us hours, minutes, and seconds. And if we highlight all this code and execute it, we've just turned seconds into hours, minutes, and seconds in a nice friendly format that is consumable by anybody looking at it. Now, a little more with parse here. Parse is great for taking strings and turning them into dates and integers. And you can see that's exactly what we're doing here with the first statement, is we're turning it into an integer. There it is. Now, let's say that we tried to do that and for some reason it had a character in it. And we're trying to convert it to an integer. What happens? We get an error. And this is why the tries are nice, because if we do that, and you can do this again with cast and convert as well. There's try versions of those. Rather than return an error, it will return a null value that we can then use to determine if it would error out ahead of time. So it's some nice way to do some defensive coding there. All right, let's move on to sparse columns. So let's say here that notes and bookmarks are sparse. And in fact, you can actually see this. Let me just give a quick select top 1000. We can see that we don't have a lot. I mean, we have enough, but we don't have a lot of information in notes and bookmarks. So we're going to say that these are good candidates to mark as sparse. And you can do that in the designer just by setting the isParse property, or you can do it in T-SQL like we're going to do it here. We're going to alter the table. We're going to alter these columns, notes and bookmarks, and add sparse to them. And then we're going to alter the table and add a new column called sparse columns as XML, mark it as a column set for all sparse columns. So let's first here just alter our table and add these sparse columns. By doing that, once we refresh our column view over here, you can see that these are now marked as sparse. Now this next part you can get tripped up on pretty easily when we're working with sparse columns. So let's say that we wanted to add a column set to a table, but our table already has sparse columns. If we execute this, it's going to yell at us. No, you cannot create a sparse column set because the table already contains sparse columns. So the workaround here, one way you can do this, and the way that a lot of people do this, is by recreating the table. And if you have data in that table, that can create quite the job. So one way to work around this is to do this. Do it backwards. So we're going to go into the designer here, go into bookmarks, scroll down to is sparse, and let's just unsparse both our bookmarks and our notes columns here. All right, so they are unsparsed. Now let's first add our column set to the table. Hey, that worked. And now let's re-add our sparse columns. And hey, that works. So we had to do that backwards. So keep that one in mind. If you ever come across this, you want to add this after the fact. The table's been out in the wild for a while. It has data in it. Don't add your sparse columns first. Add your column set, then add your sparse columns, and it will work. That way you won't have to recreate and reload your table with data. And now what's really neat about this is our inserts and our updates and our selects, we can still work with it the old way by referencing the columns individually, or we can do it using the column set. So let's add a few rows here, one using the old way of doing it and one using column sets, and that'll give us 2 rows. And then select the same way, one using the columns individually and one referencing our column set where we'll get some XML back. Check it out. So there's the first select with our 2 new data, 2 new records, and here is our second one with our sparse columns. You can click on this and there is the XML. Neat, huh? So yeah, sparse columns, that's about all you need to know about them, but they're good for, again, taking all those special case columns that have very little values in them and rolling them up into one computed XML column that'll make it easier for application developers to work with all these columns when it comes to both reading and writing. Let's move on to creating our own custom data types. And we'll start here with creating an alias data type, a data type based on another data type. And a good example here would be a URL. Let's say that we have URLs all over the tables in our database, and we wanted to create an actual URL data type. And it's really just a character field, right? So we could create a varchar, it'd be perfect for this. And the max length of a URL is 2048 in most browsers, so that's what we would make this as. And this would just ensure that number one, the storage is right, since we're using a varying character. URLs could be short, they could be long, and then we want to make sure that they never go past 2048. So let's create this type in the Nugget Demo DB database. And now I'm going to use a rule here, but rules are deprecated, so you shouldn't use them. Microsoft advises just using check constraints on columns for enforcing data integrity. So I'm going to create a rule that makes sure that anytime data goes into an object that is of URL type, it starts with http://. All right, so we'll create this rule, and then we're going to bind the rule to the data type. Cool. All right, so far so good. And you can actually view this in your database, head into programmability, head into types, and then we're going to look at user-defined data types. Let's just refresh this, and look at that. There's our URL. We can go in the properties here, and we can see everything we need to know about it. And you can also tie a default to it as well. So now we can start using our data type. And let's expand tables here. Let's say that our course table, we want to keep track of the URLs for each course. No problem. We've got some T-SQL here that'll add the course URL using the URL data type. If we hit execute, now we can refresh our columns in the course table, and look at that. There it is, course URL with the URL data type, and it even shows us the data type that it is based on. So now we can start working with data. Let's say we want to update this table and add some data into our course URL. And I notice here I have the wrong field name here, so let's just fix that. But the first update statement will succeed because it has an http://, and the second one should fail because it does not. So let's first try the first update statement. Hey, look at that, it worked. And now the second update statement, the rule shouldn't allow us, and there it is. It's telling us we are violating the rule associated with that data type. Let's move on to CLR data types. So let's say that the built-in data types didn't quite cut it, and we couldn't create your own alias data type on top of them, so you needed to create your own. And in our sample database, we have a lot of ways to describe length, and we store length as seconds, right? Duration, length, that kind of stuff, progress. But let's say that we wanted a friendly version, so we didn't have to do computed columns all over the place. So we're going to create a CLR data type that tracks minutes and seconds. So minutes, seconds is essentially what we're going to do here. And so I downloaded and installed Visual C# 2010 Express. Let's fire this up. I have a solution in here called media length UDT underscore SQL Server with one class library project, media length UDT. We have a class in here, media length, which is actually a structure. And then just make sure if you're going to do this that you reference the system.data.SQL types library and the Microsoft.SQL server.server. Referencing these namespaces will allow us to tag our structures with the SQL user-defined type attribute, which will make it visible to SQL Server so we can register and use it. Now, rather than walk through this line by line, I just want to point out a couple of interesting areas here. Number one, the toString method. You want to override this because if anybody converts our data type to a character string so they can read it, because it's going to get stored in raw format, and I'll show you when we get there. But anytime anybody converts our data type to a string, we want to support that. And we're going to do that by taking minutes and seconds and putting a colon in between, and that's what they'll get as their output. Also on the parse method, if they want to parse a string to our data type, we're supporting that as well by splitting it at the colon, storing the minutes from the left-hand side of that array and seconds on the right-hand side. And that's all the below here is those properties to store those values, minutes and seconds. So once you get your data type all coded up, you can build the assembly. Let's build it. And then just to show you where this is here, it's in our data types, max length UDT. Here is the solution. Here's the folder for the project. If we go into the bin directory into release, check it out. There it is. So that's what we just built. I'm just going to copy this with a Control-C so our path is a little easier to type out here. And there it is. So this is the DLL that contains our type. Now we can go into SQL Server. First, we need to enable the SQL CLR here. Pretty straightforward. We'll do that. Then we need to create the assembly. So this is going to create the media length UDT assembly name here in SQL Server that's going to reference the actual UDT DLL that we just created. Give it a permission set of safe. If we hit execute, that will create it. And now we can start creating types. And not too bad to do that. We do a create type followed by the name that we're going to use for this type anytime we create an object based on this type here in SQL Server, followed by linking it to the assembly. So this is going to go assembly name dot UDT name here, and you can see that by looking in your project. Here it is. Here's your assembly name, media length UDT, and then here is the actual name of our structure, media length. All right, so let's highlight it, hit execute, and there we go. Now we can start making variables, columns, parameters, whatever you want from our type. And now before we do that, let me show you where this is in Object Explorer. If you head back to your programmability area, types, and then refresh user-defined types, look at that, there's media length. And also above here is assemblies. You can see here is our media length UDT assembly. So we imported and registered the assembly, and we made a type based on the structure inside of that assembly. And now we can use it. Here's a simple usage, just creating a variable of type media length. And then we're going to set this media length equal to this value right here. And you know what? We should output that value just to show you here. If we do a select, just ML by itself, you'll be able to see what this data type looks like, how it's going to look inside of the table in its native form. And then you'll see when we cast it what it looks like. And we should get exactly what we designed it to do. So there you go. So we stored it inside of the variable. Here is what it's going to look like in raw format in the table. And if we cast it as a string, our toString method will take over and give us the nice friendly version that we were looking for. Let's take it a step further here. Let's add a column to our nugget table called friendly duration with our data type media length. We'll give it the nullability of null. And now we can update. In fact, here, let's look at that nugget table real quick here. If we go up to that nugget table, columns, there it is, friendly duration. So we have duration here, which is just seconds, and now we have friendly duration. So we're going to write an update statement that updates the friendly duration and converts the duration to the friendly form here and store it inside of that field. So let's run that update. Excellent. And now we can write a select statement that once again casts it as a character 5 field. And our results should be name sequence, original duration in seconds, and now our friendly duration here in minutes and seconds. Very cool. And the last thing I wanted to point out here is if you're going to drop any of this stuff, just make sure their dependencies are gone. So you won't be able to drop your types unless all columns are dropped that are based on that type, and you won't be able to drop your assembly unless all types that are based on that assembly are gone as well. In the CBT Nugget, we learned how to implement data types. We started off with an overview to get familiar with many of the built-in data types. We talked about some things to think about when working with data types. The big one there is going to be conversion, using cast, convert, and parse. We then jumped into the virtual Nugget Lab where we got familiar with how to convert data from one data type to another. We also saw how to work with sparse columns, and then we saw how to create our own custom data types, both using aliases, which is just refining built-in data types to your needs, and then also how to build, register, and work with CLR data types in SQL Server. I hope this has been informative for you, and I'd like to thank you for viewing.